Hello, and this is uh, one of the best videos you would love to watch. It's, it's lots of knowledge about physics. Now let's start learning. Let's get into it. Some equations you would like to know. E is equals to hc over lambda. E, that is the energy of frequency. Frequency is something we'll talk about later. H is equals to Planck's constant. And that we will also talk about later in a new episode. C is equal to speed of light, which is also in this episode but later. Lambda. I have no meaning of lambda, but I will do it if you want in a different light episode. E is equals to mc squared. You would know this famous equation from Einstein, and it's very famous. E is equals to energy, m is equals to mass, c is equals to speed of light. Energy can be converted into mass, and mass can be converted into energy. Like, let's see if you eat something, you get energy, but also you gain mass at the same time. And then if you eat something that has mass, but then it can be converted into energy to give you some energy. Okay, next page. What is weak nuclear force? Now, in weak nuclear force, there are four common things. Beta plus. Beta plus is when a proton turns into a neutron. So a quark turns into a down quark. So then it releases a positron and a neutrino. So now let's pretend this. Helium. Let's pretend that helium is a radioactive element. Now helium's mass number and atomic number doesn't matter right now, but it will turn into a hydrogen because see, the mass number will stay the same, but the atomic number is a -1. So so this will be taught this book. Okay. So now next, the equation for beta plus P is equals to so it's just saying proton equals to neutron plus positron plus neutrino. Okay. Beta minus. It's just for a neutron to turn a proton. Down quark turns into up quark. It releases an electron and anti-neutrino. Neutrons equals to proton plus electron plus anti-neutrino. So now it'll become. So now let's see. Hydrogen is Mn and atomic number. So now it will turn into Mn same, but the atomic number is +1 because see, you're added one more proton. So now alpha is when two protons and two neutrons go, and then it'll become lithium to hydrogen. Well, the atomic number is -2. So now gamma. Gamma is when gamma radiation goes out with energy photons. Photons will be talked later. They are released from the nucleus. Electromagnetic spectrum. The types of electromagnetic waves. Now, there is a spectrum of waves. If you see right here. Gamma radiation, a type of electromagnetic radiation. GRB is an abbreviation for gamma ray burst. Frequency, the amount of waves in seconds. Wavelength, the length of a subwave. Frequency. So now this is a frequency. So now look. See how many waves are in there, and then that is 1 second. Wavelength. See? So now on that you saw a tuft and a croft. There are parts of one subwave. Amplification. In that, it's the difference between tuft and croft like this. It is not the width, it is the height. Okay. So now in electricity, the voltage pushes the electrons in a current. Voltage is just actually something that pushes electrons. It's a charge difference. It's the potential difference. Resistance is what stops the electrons in the filament. Filament is actually just a fancy word saying what electron travels in for electricity. A current is just how the electrons traveling in a flow, and power is how much is actually the power of the voltage hitting the electrons. How much voltage? So now let's see the units. So volts is used for voltage. Amps is used for the current. Watts is used for the power, and ohms is used for the resistance. Now let's learn some things about a proton. Proton mass 1.67 times 10 to the power minus 27. Charge equals plus 1. Position nucleus. Neutron mass 1.67 times 10 to the power minus 27 because it's similar to proton. Charge 0 or neutral. Position nucleus. Electron mass 9.11 times 10 to the power minus 31. Charge minus 1. Position orbital. Up quark mass 2.2 megaelectron-volts. Charge 2 over 3. Position nucleus. Down quark mass 4.8 megaelectron-volts. Charge minus 1 over 3. Position nucleus. Now here is the table of it with some of the particles. Now the first row of leptons. Leptons are a group of particles. They are not interacted with strong nuclear are these. First row of leptons are a minus 1 charge, and they are electron, tau, and muon. They all have minus 1. And second row of lepton is electron, neutrino, tau, neutrino, muon, neutrino. They are all types of neutrino. Neutrino is a type of particle that with a 0 charge, so it's neutral. Now in the quarks, there's up and down and charm. So up, charm, and top. They all have a 2 over 2 charge. Down, strange, and bottom, minus 1 over 3 charge. So now that is good knowledge to know. So now let's see. Quarks. They also make up the atom like leptons, and they are fundamental or elementary. They are fermions. So it's a type of statistic in composition. Okay, so now more things on my table. They also show types of they are showing more types of particles like gluon, photon, Z boson, Y boson, Higgs boson. They're all types of particles. Now, those are types of bosons. So now, more equations, and they are maths ones like the others, except for they're dealt with maths mostly, not physics mostly. Area of a circle is equals to pi r square. The circumference of a circle is equals to 2 pi r. And the diameter is equals to 2r. Now, you would think, what is pi? Are we talking about a circle? That's a good knowledge to know, and it's a very good joke. But pi is a type of number. So you can you won't like to round it off, but if you want to round it off, it's close to 1 and 2. So now r is equals to d over 2. What are you thinking? Like, what are these letters? Well, r is radius. So now let's pretend there's a circle. There's a center of the dot. Now you can half it. That is the radius. But all of it together is a diameter. Okay. So now you understand. So just saying, area of a circle is equals to pi times the radius squared. Okay. Now circumference of a circle is equals to 2 times pi times radius. D is equals to 2r, so it means 2 times radius. So now let's check. So now there are, so let's see, r plus r equals 2r, otherwise it's d, because see, there's 2. You can't multiply r times r equals r square, okay? So it can't be, it has to be 2r. Now r, so now r is equals to d over 2, because remember, if you rearrange it, it'll become d over 2. So diameter divided by 2 equals r. Next page. Now we're come to the one that it was at the start. Atomic number is the number of protons. If in hydrogen there is 1 proton, mass number is the sum of neutrons and protons. Now energy state is equals to orbit, and a sub-energy state is orbital. So now let's see, this is an orbit, like Bohr said, this is some orbit, there's a spin. Orbital is like a sphere or something, any 3D shape will do, except for cube. Now orbits, there can be 1, 2, 3, 4, 5, 6. Orbital, SPDF. So there can't be more orbitals than SPDF. N is equals to the amount of orbits. Now we're talking about the Pauli exclusion principle. So N is equals to amount of orbits. L is equals to 0 to 3. So like if N is equals to 1, then L is equals to 0. N is equals to 2, L is equals to 0 or 1. N is equals to 3, L is equals to 0, 1 or 2. N is equals to 4, L is equals to 0, 1, 2, 3. N is equals to 5, L is equals to still 0, 1, 2 or 3, because remember, there are only 4 orbitals, so it can have only that. MS. So now that is the spin, so it can be 1 over 2 or minus 1 over 2. And the last one, ML, is the negative and positive of L. So like if L is 0, 0 and 1, it must mean minus 1, 0 and 1, okay? So now the amount of the orbitals, S is equals to 2, P is equals to 6, D is equals to 10, and F is equals to 14. See the difference? It's plus 4 difference. Orbits, 1 is equals to 2, 2 is equals to 8, 3 is equals to 18, 4 is equals to 32, and then it still goes on as 32, because at the orbitals it becomes 32. So that's the maximum we can go to. In Bohr said there is only a spherical or just a circular orbit, but in reality it's just orbital sphere or 3D shape. So now let's see, 1s, 2, 2s, 2, 2p, 6. So now in 2p there can be 3 things, x lines. Okay, so now let's see. So now let's go to this. So now let's see. Let's do an example like element number 9, fluorine. So 1s will be 2, 2s will be 2, that's 4, and then it will become 2p5 because it can't have 6, otherwise it will become 10. So it has to be 2p5. So 2, 4, 9. Okay. So the shapes, S is equals to sphere, P is equals to dumbbell, D is unsymmetrical, and F is unsymmetrical. So now let's go to light. It's an electromagnetic wave with photons in it. Photons are particles that are in electromagnetic waves. Light is a wave and a particle. So the wave is electromagnetic wave and the particle is photons. Now in reflect, light comes and hits something and then goes back. So you know whenever you stare in a mirror, so there is light. So without light we can't survive. So that's possible. So now light will hit the mirror, okay? Then the mirror will reflect back on you, so you can see yourself in the mirror. In refract, pretend there's a pencil in water. So now light will go, and then when the light enters water, remember water constantly moves, so the light will change direction always, and then the shape, it reflects on the pencil, and then the pencil will look different because of the moving of the light. Now diffraction, it can be only used in slits. So now let's see, so light enters two splits and then splits up because they are diffracting. Thanks for learning with me today. I hope you learned some facts. Now let's learn some new facts in another episode. Bye.